Okay, we're ready for the 6C Notes for the Math 4 course. And this one I have to point out that that little blue thing at the top of the graph is not the top 1%. That would actually be the middle of the group. The average of the group would fall into that area. If you want the top 1%, you got to go all the way to the right side of the graph. All right. And speaking of, we're going to spend today reviewing some things about box and whisker plots and also normal distribution, standard deviation, and that sort of thing. And we're going to look at a number of the graphs, look at making choices of graphs, and that's increasingly where we are directing you is, at some point you got to ask yourself the question, how do I create a graph to represent the thing that I need out of this data set? Because we're still going to be playing with that data set from the school questionnaire, which there are just dozens upon dozens of different data points that are being asked there. So how do you create a graph to represent what you need to know about this? That's going to be one of the underlying questions that we're going to address later on. All right, first of all, let's look at box and whiskers plot. The idea that you are going to take all of your numbers and you're going to line them up in order from smallest to the largest. And then you're going to figure out where is the median, where would I cut it exactly in half. And once my butter stick has been cut in half, then we're going to cut it in half again and make quarters out of it. And so Q1 and Q3 represent that effort to cut up the butter stick a second time. Now, one of the things that we're going to be talking about here, one of the ways that we can discuss spread about a data set is with things like the range, which is from minimum to maximum, and the interquartile range, which is from Q1 to Q3. And so we're going to look at some number sets here, and we're going to start asking, how can I identify these things? Now, and I can't believe this, I wrote mean, and I should have written median. That's what I get for doing this when I'm asleep at night. Quartile 1 median and quartile 3, along with range and IQR. Now, the idea, there should be a sense of symmetry about this. If you're going to try and find the median in the middle, then you're going to kind of create the rainbow effect here. And you're going to look for who's in the middle. Because at this point, 6 is in the middle. That is my Q2, that is my median. That is where I cut this exactly in half. Now, I don't need this anymore. Now, there's something that you need to understand about when we go back for the second round and we cut each side in half. Because 6 has been identified as the median, you're not going to use them again. When we're talking about cutting the left and the right in half, you're going to ignore the 6. You're going to say 7 through 11. That's 5 numbers. That means that the 9 in the middle is going to be my Q3. Likewise, over here, 1 through 5, my 3 in the middle is going to be Q1. Now, range is basically the biggest number minus the littlest number of a range of 10. My interquartile range is going to be Q3 minus Q1, which is 6. Now, I need to kind of give you an idea here. There's a concept here that I'm not going to hammer on this time. We may come back to it later on in the course, and that is the idea of the outlier. And what I do is I take 1.5 times the IQR, which at this point is 1.5 times 6, which is 9. And then I do 1.5 IQRs. Let's see, I'm doing this backwards. We're going to say Q1 minus that and Q3 plus that. And whatever that gives us, now remember we said the 1.5 IQR in this case is 9. So if I take this and I subtract 9, I'm down here at negative 6. If I take this and I add 9, I'm up here at 18. Now here's the deal about outliers. Anybody who lives outside of those boundaries, lives above the 18 or lives below the negative 6, those would be considered outliers. Now obviously this data set does not have any outliers because everybody lives comfortably inside of that range. But that's what you would do to try and figure out if there's an outlier, is figure out the IQR, figure out 1.5 times the IQR, then add it to Q3 and subtract it from Q1 and see if anybody in your data set lives outside of those extremes. All right, now let's move on to the other ones. Now you probably noticed that we did 1 through 11 and 1 through 12 and 1 through 13. And there is method in my madness, because when we're looking at 12 numbers and we try to cut them in half, I'm going to get exactly 6 on each side. 1 through 6, 7 through 12. Those are 6 numbers on either side. So I'm going to take, it falls in between the 6 and the 7. So I'm going to take the 6 and the 7, and I'm going to average them. Now that gives me 6.5 as my median. And then we're going to come back, and because my median fell between the numbers, and I'm going back to try and figure out how do I cut this in half, how do I cut that in half. The 6 and the 7 are going to be counted with these other numbers because they were not nailed by the median. So I've got 6 numbers here. It's going to fall between the 9 and the 10, which is going to give me an average of 9.5. Now that's going to be Q3. And the 6 numbers on this side, I'm going to fall between the 3 and the 4, which is going to be 3.5, and that's going to be Q1. So I'm going to come over here and I'm going to say that my range is 11. IQR is going to be 9.5 minus 3.5, which is 6. Okay. Now, when we get to 13, something different happens. Every time that you have an odd number like this, like 11, you have 1 in the middle. Well, this one, you're going to have 1 in the middle. It's going to turn out to be that one because you'll have 6 this way and 6 that way. So that is going to be my Q2. That is going to be my median. Now, when I go to try and cut these other guys in half, there are 6 numbers here, so it's going to fall between the 10 and the 11. And it's going to fall between the 3 and the 4. Oops, that's 1 and that is 3. All right, so our range is going to be 13 minus 1. 10.5 minus 3.5, which is going to be 7. Now, I will say this, that I'm getting ready to show you some shortcuts, especially with Desmos. We're going to go to Desmos today. We're also going to go to the Codab file of that school survey set. But in any case, when we get to Desmos, they're going to have buttons that you can just type this whole set in there, And there's a whole bunch of things you can find out about that data set, including what the range is, what the the quartiles are. So we're done with that. Now we're going to move on to normal distribution. Now I'm going to write that word here. Normal distribution is our umbrella term for all of this right here with the bell curve and the standard deviations and the mean in the middle. Normal distribution is the umbrella term for all of this. Standard deviation is just simply a description of spread away from the mean. You know, how far spread out is this data set? Is it all clumped up together tight, or is it spread out pretty widely? We don't know until we get there. So this is where Desmos is going to help you greatly. So I'm going to shrink that page, and I'm going to bring him over this way. And then I'm going to go into Desmos and shrink that page and put him right there so that I can put a table in. And we're going to type in all of the test scores that we're seeing there on the left, 67 and 98. Now, this is not something that you want to put a second set of numbers with. You're not going to number them like 1, 2, 3, 4, 5. We're just going to put in that one row of values. And then we're going to go here, and I'm going to go ahead and blow this. Well, maybe I don't want to blow it up all the way. Let's do it this way. We're going to click on the keypad, show the keypad, and over here where it says functions, we're going to bring up stats. We're in statistics. All right, the mean, you click on that, and it's going to give you a parenthesis. Now what it's looking for is that this whole list of numbers was x sub 1. So you're going to put x sub 1, close the parenthesis, and look over to the right side. There's a little gray box that's got 82.1. That's the mean. Now I could start another one, functions, and I could do median. And the median would be x sub 1, close parenthesis. So my mean is 82.1, my median is 87. And lastly, I'm looking at standard deviation, STDEV. And it tells me my standard deviation is 17.8. My mean was 82.1. So I'm going to come over here, and I'm going to write that down, that my mean was 82.1, my standard deviation was 17.8. Oops, that's not what I wanted to do. Now, what's going to happen here is that I'm going to have 82.1 here as my mean. But as I move to the right, I'm going to keep adding a standard deviation. 82.1 plus 17.8 is going to give me 99.9 plus 17.8 is going to give me 117.7. Now, as I'm thinking about it, it makes no sense for my test scores to go above 100. So I can kind of stop there. I am going to have there was 100 in the bunch. So he is going to be just slightly outside of one standard deviation. but that probably does not qualify him as an outlier. Now, when I start going the other way, I'm going to get 64.3. I'm going to get 46.5. I still have a 40 in my scores, so I'm going to take it all the way down to 3 standard deviations. 15 minus 7, 3 minus 1. So that's going to be 28.7. Now I had a 40 that probably was right about there. And then my next highest score was 67, which would have been up here inside of this region. Now I will say this, that this region right here and right here is supposed to represent 68% of all the data. That is typically the way that that happens. Now, there are some occasional, Murphy's Law kind of situations, but most will fall in really close to that. So that's as far as we're going to really go with standard deviations and normal distribution. The good news is that there is a button on Desmos that if you type the list in there, it'll tell you what the normal distribution is. The standard deviations, the mean, it'll give you all the players in that. All right. So moving on to the next set, we're going to look at some Codab graphs. These are ones that I just kind of grabbed some random stuff. And I'm showing you what the graphs are capable of. Now, first of all, this was favorite season. I grabbed that as a data set. Fall, spring, summer, and winter. I went to, I clicked on it and I said, make it categorical so that I would have a bunch of dots. And then I clicked on the graph thing here and said, fuse the dots to make a bar graph. So that's what's happened so far. Now on ruler, I'm saying count. Show me the count. And if you'll look up here, every single one of them shows you how many respondents fell into that category. Now, the thing is, if you add them up, they probably are not going to add up to 500 because not everyone answered this question in the survey. Some left it blank. You probably have, let's see now, that's 298 and 140. It's going to be about 440 some odd, which the sample pulled out 500 names. So there's about 60 people that did not answer this question. Now, I'm going to undo the count, and I'm going to do the percent instead. And notice that the percents are at the top. Now, usually I'm hovering my cursor, and I get these pop-ups when I don't want them. This is probably one of those kind, if I were going to do that, I'd do it with the biggest one. But it worked out that way. Now, one thing that I want to notice here is that we have chosen a topic, favorite season, fall, spring, summer, winter, where you don't, these are categorical. You don't have numbers, you have categories, fall, spring, winter, and summer. And because of that, you've got things like standard deviation that's missing, mean, median, mode is missing. A lot of those things are missing because you're dealing with categories, not with as much numbers. Yes, you want to know what percent responded to each, but you're kind of limited with a categorical topic. Now, this one, I switched topics and I said ring finger length in millimeters. Now, I find it curious that there's a bunch over here, and we'll talk about that in a minute. Most everybody fell into this category. And what I did was I did, the categorical thing at the bottom. And I came over here and I said, let's take the dots and fuse them into bars. But then I also said I want bins, which means that I'm clustering everything from 60 to 80, everything from 80 to 100. They're all clustered together. And the other thing is that this gives you the opportunity to change the bin width, that you can go with 10 or 15 instead of 20. Now, the problem I find with histograms like this, and this one is definitely a histogram. When you have levels like that where it's not, it's between 80 and 100, that there are like 120 some odd that aren't answered that way, but you don't know exactly where between 80 and 100 that each one landed. So histogram is good about showing you general relationships, but not a whole lot of specifics. Now, let's look at the next one. This one I did not fuse into bars, but I did click on box plot. And what this is doing is this is showing each dot represents one kid in the survey. And if you were to click on that dot, it would light up green, and in your big old spreadsheet, you would have a green line through that representing that kid. Now, when I ask for a box plot, I'm getting Q1 here, and Q2 here, and Q3 there. And I know what my max is, and I know what my min is. As a matter of fact, while this is still on Codab, you can hover on Q1 and you'll get a number. Hover on Q2, you'll get a number. It'll tell you exactly what the values of these guys are, so that you could do Q1 and Q3 and you could figure out what's the interquartile range. So this can be helpful. One thing to remember is that a box and whiskers uses the median. Your middle here is the median. Whereas when you start talking about standard deviation, your middle is not the mean, it is the median. And then you've got Q1 over here and Q3 over here. And so this will give you an idea of where the majority of it. Now, I do want to, well, let's move on to the next one. The next one is talking about mean and median. And in this case, they're not quite the same. Matter of fact, I would say they're almost 10 apart. You have boxes that you can check along with, standard deviation, box plot, all of these. But the difference is that I had access to the really cool stuff over here because I had numbers on the bottom and not categories. All right, this is more of a quantitative kind of deal. But the blue line represents mean, and the red line represents median. Now, why is the mean? The mean is the average. Why is the average to the left of the median? One reason might be this guy right here. That whole thing is like a cluster all to itself that is not with everybody else. It's like down here. The only thing I can figure is that they're asking for your finger length, your ring finger length in millimeters. And so if you decided to give it to them in inches or even centimeters or something like that, you're going to wind up with an answer down here. So this tells me how many people have problems paying attention to units and giving the units that we asked for. But the thing is, because we have this cluster down here, this is what we call skew left. This group down here is taking the average and skewing it to the left side so that mean and median are not in the same place. Now I got so many down here that it's throwing my average lower, and that's what's going on here. All right, let's move on. Let's talk about things that you can gather from each one of these. The box plot is going to give you a checklist of information. You're going to get a minimum value. You're going to get first quartile. You're going to get the median in the middle. You're going to get quartile 3. You're going to get the maximum value. You also should be able to name things like the range and the IQR. And we talked about how the IQR can lead you to identifying outliers. So all of those are a possibility with a box plot. That's why a lot of statisticians use the box plot, is because it gives you this treasure trove of information. Scatter plot is not so much. Scatter plot takes two variables and it will show you things like trends. It will show you things like correlations, whether it has a positive or a negative correlation. Histogram is not very specific. And I guess you would say it too indicates trends. The real problem with a histogram is that, it deals with intervals. It has this bar that's between 10 and 20. And our problem is that we can't be any more specific than that. I know that, judging by the height of the bar, there are 3 data items that fall between 10 and 20. I have no idea where between 10 and 20. I can't be that specific. And so when they start asking you things like, so where's the mean or the median? The best you can do is say, I can only venture a guess as to which interval that it lands in, but I can't be any more specific than that. So, histograms are good at giving us a sense of relationship, but not much on specifics. And the dot plots, we can definitely look at things like frequency. Even relative frequency we can get from that. You can look at all of the dots and realize, well, half the dots are here. That's a relative frequency. That when you're putting a fraction or a decimal or something like that to it and saying, well, 50% of it, of all the dots happened here and here. That's relative frequency. All right. Now, display and paste below a graph that would answer the question, how does handedness differ by gender? Now, what I'm going to do is I'm going to switch over to this guy. And let's see, now we're going to come back here. I don't need him. Now let's stretch this out a little bit more. Now, one thing that we had a little headache with last time was the idea that if I had 40 items across the top and I wanted to get somebody on the end, I was going to have to stretch and drag and stretch and drag. Well, I found a shortcut, and that is this little corner right here on the green box. This little corner will give you the option to switch, and it's now just going to list the different items. Excuse me. Your different data groups, and this makes it much easier because if I'm going to do this, I'm going to get a graph going, and I'm going to say handed, that is left-handed, right-handed, ambidextrous. We'll drag that there. Now, if I wanted to, I'm curious to see what happens. Let's fuse the dots into bars and then drag gender over and put it on the left side. Let's see if it'll let me keep the bars. Nope, it goes back to dots. When I do, and what's at stake here? You got to realize that, left-handed and right-handed, this is a categorical thing. These are not numbers, these are categories, and all of these dots, you click on one, that represents one kid that answered the survey. And it'll show you on the graph, all 40 things that kid said. But here, as I hover, I'm only getting individual, responses from each kid. Now, watch what happens when I do a second one. We're going to drop the handed back down here on the x-axis. But at this point, I am going to go ahead and fuse the dots into bars. But instead of bringing gender, dropping it in the main, dropping it on the y-axis, we're going to drop it in the middle. Okay, and I dropped it in there, and your genders suddenly turned into colored bars. That's not what I wanted to do. In any case, I would almost suggest a screenshot of both of those. Because one gives you the individual dots, so it's a little bit more of a visual representation of what's going on with the different kids and their survey responses. But the one on the right, when you hover, you get relative frequency. 52% of the females, 48% of the males are right-handed. And so it gives you an idea of the relationship between gender and what hand you favor. So that's all we're going to do with that one. Let's answer some questions about it, though. There. All right, so let's answer some questions. How did the data display help you find your answer? And I would say that the segmented bar graph, the yellow and the purple, gave us frequency. Oops. Gave us the frequency of each vote, as it were. Now, determine whether the data is discrete or continuous. Well, we're still talking about ambidextrous or left-handed or right-handed. Those are categories. Those are definitely categories. So, I would say that this is more discrete than it is continuous. Discrete is something that, lumps into groups rather than is one continuous number line. Now, does that make it quantitative or categorical? I think we've discussed this before, that this is definitely categorical. Now, why do you think the variables of gender and handedness led to this graph? When you think about it, both of them are categorical. And frequency was the best we could do. Okay. And that is the end of the notes.